Space, to the naked eye, looks full of stars. The night sky glows with light, thousands of points scattered across the black. But if we could step back, far beyond our galaxy, and look at the universe from a cosmic distance, we would see something astonishing. Most of space isn't full at all. It's almost completely empty. Between the great filaments of galaxies and clusters lies a vast darkness, a web of nothingness known as cosmic voids. And here's the mystery. Evidence suggests that our Milky Way, our home galaxy, might sit right inside one of these enormous voids. We might be living in a region of space less populated than most of the universe, a bubble of near emptiness spanning hundreds of millions of light years. That realization changes how we think about everything, from the expansion of the universe to our place within it. It raises unsettling questions about whether what we see from Earth truly represents the cosmos at large, or whether we are observing from an unusual, lonely vantage point in a vast cosmic desert. To understand what it means to live in a void, we need to understand how the universe is built. On the largest scales, galaxies are not scattered randomly. They form a structure known as the cosmic web, a vast network of filaments, clusters, and walls surrounding immense, nearly empty regions. These voids are not small. Some stretch over 500 million light-years across. They are the dark spaces between the luminous threads of the universe, like the gaps in a sponge or the empty cells of a honeycomb. The cosmic web formed from tiny fluctuations in the early universe. Regions with slightly higher density of matter grew over billions of years into clusters of galaxies, while lower density regions were left behind, expanding faster and thinning out even more. The result is a universe shaped like lace, bright filaments of galaxies surrounding enormous cosmic cavities, and it seems that our own galaxy, the Milky Way, may lie in one of these cavities. The idea that our galaxy sits in a void isn't new. Astronomers have long known that our cosmic neighborhood is relatively sparse compared to denser regions elsewhere. In the 1980s, researchers studying galaxy distributions identified what they called the local void, a massive region of underdensity adjacent to the Milky Way. Over time, new observations refined this idea. Surveys of nearby galaxies showed a peculiar pattern. The Milky Way and its neighbors sit at the edge of an emptiness stretching for tens or even hundreds of millions of light years. This void appears to be pushing nearby galaxies away, as if the Milky Way is perched on the border of a vast, invisible bubble. We are not in the densest part of the cosmic web, like a busy galaxy cluster. Instead, we inhabit a quieter suburb of the universe, a region of low density, a cosmic cul-de-sac surrounded by more crowded neighborhoods of galaxies. Living in a cosmic void doesn't change our everyday lives, but cosmologically it's profound. The density of matter, both visible and dark, affects how space expands. Regions with more matter expand more slowly under gravity's pull. Regions with less matter expand faster. If the Milky Way lies in a low-density void, it might mean that the universe around us expands slightly faster than average. That could subtly influence our measurements of cosmic expansion, the rate known as the Hubble constant. In fact, one of the great tensions in modern cosmology, the discrepancy between the local measurements of the universe's expansion rate and the values inferred from the early universe, might be explained, at least in part, if we live in a void. From our position, surrounded by emptiness, light from distant galaxies might appear to stretch more than expected. In other words, our cosmic address could be skewing our perception of the universe itself. Astronomers have gathered several lines of evidence supporting the idea of a local cosmic void. Large-scale galaxy surveys, like those from the Sloan Digital Sky Survey and the 2-mass redshift survey, map the distribution of galaxies across space. These maps reveal that while vast filaments and clusters fill the cosmos, our region appears unusually underdense. Measurements of galaxy motions also tell a story. Galaxies near the edge of the local void seem to be moving away from it, pulled toward denser regions beyond. It's as if gravity from neighboring clusters is drawing them outward, leaving behind a growing bubble of emptiness. Computer simulations of cosmic evolution suggest that voids naturally form as gravity draws matter into dense filaments, draining the spaces in between. If the Milky Way happens to lie near the boundary of one of these expanding voids, that could neatly explain the observations. For years, astronomers have struggled with an odd discrepancy. When we measure the expansion rate of the universe using distant cosmic background radiation, the afterglow of the Big Bang, we get one value. But when we measure it using nearby galaxies and supernovae, we get a faster rate. This is known as the Hubble tension, one of the most intriguing puzzles in modern cosmology. One proposed explanation is that we live in a local void. If our region of space has a lower matter density, it would expand slightly faster than average. That local acceleration could make the universe seem to expand faster when measured from Earth, even though the overall cosmic rate remains consistent with early universe predictions. The void hypothesis doesn't solve the entire problem, but it offers a fascinating possibility. The disagreement between measurements might not reflect new physics. It might reflect our unusual cosmic address. From our galactic perspective, the void doesn't feel empty. The Milky Way, Andromeda, and the local group form a cozy cluster of galaxies bound together by gravity. Beyond them, other galaxies fill the sky. But on the grandest scales, our neighborhood is quiet. We are not surrounded by vast galaxy clusters or dense cosmic walls. Instead, we reside near the boundary of emptiness, a rarefied region where the nearest large concentrations of matter lie hundreds of millions of light-years away. In a sense, the Milky Way is like a solitary island, surrounded not by ocean but by a great cosmic desert. Our stars, our planets, our entire history, all unfolding in a lonely corner of the universe's web. This solitude doesn't diminish our importance, it magnifies our sense of wonder. Against all odds, life has arisen not in the bustling heart of a galaxy cluster, but in the stillness of a cosmic void. Cosmic voids might sound exotic, but they're actually a natural and common feature of the universe. Roughly half of all space by volume lies within these vast, underdense regions. The filaments of galaxies and clusters that form the cosmic web make up only a tiny fraction of the universe's total structure. Voids come in many sizes. Some are small, tens of millions of light-years across. Others, known as supervoids, span hundreds of millions of light-years. The local void, depending on how it's measured, may be as large as 200 million light-years across. So in a cosmic sense, our home isn't an outlier. It's part of a natural pattern. The difference is that we might happen to be near the center or edge of one of these vast bubbles, giving us a unique vantage point on the universe's architecture. Astronomers are still charting the void around us, using increasingly precise measurements of galaxy distances, motions, and redshifts. By combining this data, they can build three-dimensional maps of the nearby universe, maps that reveal not just where galaxies are, but where they aren't. The picture that emerges is striking. Our Milky Way lies on the edge of a vast emptiness, bordered by denser regions like the Virgo cluster and the Great Attractor. These dense areas exert gravitational pull, slowly stretching the void and moving galaxies like ours outward. The void is not static, it's evolving. As matter flows toward denser filaments, the emptiness grows, the local void expands, and our galaxy drifts ever so slightly along its boundary, a silent traveler at the edge of the great nothing. The idea that we live in a cosmic void carries a quiet poetry. It suggests that emptiness is not absence but structure, that the universe's beauty lies not only in the galaxies and stars, but in the spaces between them. It also reminds us of perspective. From our small world, we often feel central, as though the universe revolves around us. But on the cosmic scale, we inhabit a region of quiet, a low-density corner of the grand design. Perhaps this solitude is what allowed us to exist. A calmer environment, free from the gravitational chaos of dense clusters, might offer stability. It may be precisely because we live in a cosmic void that our galaxy and our fragile species could evolve in peace. As time passes, the local void will continue to expand. Matter flows outward, galaxies drift apart, and the universe grows ever emptier. The Milky Way and Andromeda, destined to merge billions of years from now, will remain gravitationally bound, but beyond them, the cosmic web will fade. Eventually, even the nearest clusters will slip beyond our visible horizon. The universe will appear darker, quieter, more isolated. The cosmic void that now surrounds us will stretch beyond imagination. Yet within that emptiness, the stars will continue to shine. Life, perhaps somewhere else, will look up and wonder, just as we do, how such beauty can emerge from such profound nothingness. The discovery that we may live inside a cosmic void transforms our understanding of the universe and of ourselves. It reveals that even in the greatest emptiness, there is structure, motion, and meaning. We are the observers on the edge of a vast silence, measuring the echoes of creation from a quiet corner of space. Our galaxy drifts through the cosmic web, not from its center, but from a lonely vantage point, surrounded by darkness. And yet, in that darkness we have found light, stars, planets, life, and consciousness. From a void we have built understanding. From emptiness, we have found wonder. Perhaps that is the universe's final lesson. That meaning is not confined to the crowded places, but arises from the quiet ones, the still spaces where the cosmos has left room for reflection. The Milky Way may lie in a cosmic void, but in that vast emptiness, we have discovered everything.